Hello everyone, this is Alicia Gonzalez, and today I will be giving a short demo on one of the chapters in chemistry, and the name of the chapter is Chemical Equations and Chemical Reactions. So before I proceed, I will be sharing my screen and I will be talking at the same time. So yeah. So talking about chemical reactions and chemical equations. If I ask you a question about what a chemical reaction is, some of you will say a chemical reaction is a thing where two or more compounds combine together. Some will say that two different substances combine together to give different substance, or a new substance is formed. You can say that as a chemical reaction. Now both the sentences are true. But whenever we study chemistry, whenever we study science, and whenever there's a question asked in examinations, it is very important to give the right definition with the right words. And today I will be teaching you all how to balance a chemical reaction. And before that, I will be telling you what a chemical reaction is and how we can proceed along with it. So before we begin, I will be sharing 3 activities with you all. And upon those 3 activities, we will then get to know how to define a chemical reaction or what a chemical reaction actually is. Okay, so the first activity, as you can see in the frame, someone is taking a pair of tongs and they are using a magnesium ribbon and a pair of tongs. They are holding the magnesium ribbon with a pair of tongs and they are trying to burn the magnesium ribbon. Now the magnesium ribbon, which was in a solid form or which was in the form of a ribbon, after burning, it will turn into ash. Okay. Now the form of ash or the chemical composition of ash is completely different as compared to that of a ribbon. Its form has changed, its shape has changed, and many different things have changed. So here you can see a chemical reaction is occurring. Agree, a chemical reaction is happening. But how is the reaction happening? If someone asks you this question, then your answer should be magnesium ribbon, which is Mg, when heated, it reacts with the oxygen which is present in the air, and hence it forms a combination of magnesium oxide. So the ash which we get is nothing but magnesium oxide. Okay. So here you can say that in this chemical reaction, there was change in form of the substance, where the magnesium ribbon reacted and it formed into ash. You can say that this is a chemical process. This is an irreversible process. What do you mean by irreversible process? An irreversible process is a process which cannot be reversed. For example, if you're burning a magnesium wire and it is turning into ash, you cannot turn that ash reversibly into a ribbon again. Once it is ash, it is ash. You cannot form it into a ribbon again. So this is an irreversible reaction and it is a chemical reaction where magnesium is reacting with oxygen to give magnesium oxide. Okay, moving ahead. In the second experiment, they have taken 2 conical flasks, as you can see in the picture, and once they put a balloon over it, you can see that the balloons are inflating or they are blowing. Now, what is the reason behind that? Inside this conical flasks, they have added zinc granules. Okay, zinc granules were in solid state, which they added, and upon that, along with the zinc granules, they added dilute hydrochloric acid. Whenever I use the word dilute, it means that I have mixed the particular chemical with water. So it is a dilute hydrochloric acid, and when we mix zinc with dilute hydrochloric acid, there is a reaction which occurs, and that because of that reaction which occurs, it produces hydrogen gas. And hydrogen is a gas, and we all know that gases have a property that they flow easily. And because there is this hydrogen gas which is produced, and if you put balloons over it, you will see that all the hydrogen gas is entering into the balloons, and hence you can see that the balloons are inflating. Now let's see what actually happened. What type of chemical reaction actually happened here. Moving ahead. Zinc. Zinc granules, the element zinc can be detected as Zn, and HCl is nothing but a hydrochloric acid. It reacts to form zinc chloride, that is ZnCl2, and hydrogen. ZnCl2 is a liquidy substance which is formed, and H2 is a hydrogen gas which is evolved, and that is the reason why you can see the balloons are inflating. Now, this also is a chemical reaction in which the state of the reactants are changing. The state is changing. Previously, the form was changing. Now you can see the state is changing. Now let's see to the third experiment or the third activity. Here what they have taken is, they have taken a lead nitrate solution and a potassium nitrate solution. They took these two solutions, lead nitrate and potassium nitrate, and then they mixed these two solutions. Once they mixed these two solutions, there was a reaction which occurred between the lead nitrate and the potassium nitrate, wherein the lead nitrate, that is lead nitrate, that is PbNO3, reacted with Ki, that is potassium iodide, to give KNO3 and PbI2. Now, these are the two substances or the two products which are formed for the reaction, and you can see that in this reaction, when these two mix, you see a yellow precipitate which has formed. Now, this yellow precipitate which has formed is nothing but the color change and the precipitate. Now, precipitate is something which is pulpy or insoluble which is formed, as you can see. So here also you can say that a chemical reaction has taken place. So now if I ask you to define a chemical reaction, what would you say? I'll tell you what to say. And it is when two or more reactants react together. Now what are reactants? Reactants are those substances which are reacting or which are combining to give another substance. So the ones which react in first place are called as reactants, and the new substance which is formed is called as the product. So you can say when two or more reactants can be two, reactants can be more than two. So when two or more reactants react together to give you products, you can say that a chemical reaction has taken place. Correct? That is how you can say that a chemical change leads to a chemical reaction. And to define, you can say when two or more reactants react together to form products, you can say a chemical reaction has taken place. Okay, now let's look at this equation. This is the equation from our very first experiment, wherein magnesium and oxygen are reactants and magnesium oxide is the product. So your magnesium and oxygen react together to give products. Okay, now magnesium is represented as Mg, oxygen is represented as O2, and magnesium oxide is represented as MgO. These are the chemical formula for each of the compounds. We cannot afford to write the big names of chemical compounds while writing a chemical reaction, and that is why these short forms are used. Okay, so Mg plus O2 gives you MgO. If you look carefully at this equation, if you look carefully at this equation, what will you observe? Is this equation complete? I would say the equation is not complete. Then how do I say how to complete this equation? You can see that here in the reactants, there is only one magnesium. And here at the products also there is one magnesium. But if you look at the oxygen in the reactants, the oxygen which was reacting is not equal to the oxygen which has formed in the product. That means this equation is incomplete, it is unbalanced. And every time, whenever you write a chemical reaction, it is very important to balance a chemical reaction, because balancing a chemical reaction is very, very important. Okay, now everything happens for a reason. So the question will be, why is it necessary to balance the equation or a chemical reaction? And the reason behind that is the law of conservation of mass, which states that mass can neither be created nor be destroyed in a chemical reaction. Means if two oxygen atoms are reacting, in the product also you should get two oxygen atoms only. That is, the mass of all the elements which are reacting should be equal. The mass cannot be gained nor it can be destroyed. And this is the law of conservation of mass, and that is the reason why we have to balance all the equations. Moving ahead. Now let's see how to balance the equation. It's going to be fun. Now here there is one equation which is given where you know that in the reactants zinc and sulfuric acid is there, and in products zinc sulfate and hydrogen is formed. okay, where hydrogen is a gas and zinc sulfate is formed, and this is the equation. Now, to see whether or not the equation is balanced, there's a very easy technique which I'll tell you. You have to make a table, okay, in which you have to make 3 columns, one for elements, one for number of atoms in the reactants, and one for the number of atoms in the products. Okay, now in elements, you have zinc, you have hydrogen, you have sulfur, and you have oxygen. These are only 4 elements which are reacting, and these are the only 4 elements by which we are getting products, correct? See, because here also you have zinc, you have sulfur, you have oxygen, and you have hydrogen. Don't look at the numbers right now. Let's see what are the elements. So I wrote all the elements here. Okay, all the elements are written here. There are 4 elements. Now, start filling in these boxes. How to fill in? First, look at the reactants. Reactants are on the left-hand side of the reaction. Products are on the right-hand side of the reactants. So zinc here is a reactant. And you can see that there is only one zinc. So I wrote the number 1 there. You can see that there are 2 hydrogens here. So I wrote 2 in the reactant side. Sulfur is 1 and oxygen is 4. And I wrote it. Looking at the right-hand side or the product side, zinc is 1, S, that is sulfur, is 1, oxygen is 4, and hydrogen is 2. Now compare the 2 columns. Zinc, hydrogen, sulfur, oxygen. Check. All are right. Isn't it? All are equal. That means this equation is already balanced and you don't have to do anything to balance this equation ahead. Okay, but in case the equation is not balanced, then you need to balance the chemical equation. Let's see how to balance the chemical equation. Here, I have put an example of iron, that is Fe, when reacted with H2O, that is water, gives you Fe3O4 plus H2. Okay, now, first step, always the first step is you have to check whether the equation is balanced or not. So as I told you, you have to make 3 columns, elements, number of atoms in reactants, and number of atoms in products. You write Fe, hydrogen, oxygen, because these are the only 3 elements which are present in this reaction. So you wrote Fe, you wrote hydrogen, you wrote oxygen. Now start counting. Fe, you have only 1 here. But here you have 3 Fe, so you wrote the number 3 here. Hydrogen on the left-hand side or the reactant side are 2. On the product are also 2. Oxygen on the left-hand side is 1 and on the product side are 4. Now you see the equation is not balanced. And now we need to balance an equation. Moving ahead, step number 2. So step 1 is list the number of atoms and elements present on both sides of the equation. Coming to step number 2. I have written the equation above so that you can refer to it. In step number 2, start balancing with compounds which has the maximum number of atoms. So in this equation, you can see that oxygen has the maximum number of atoms. So, and that oxygen is present with Fe3O4 here. So they are starting to balance these first. So what did they write is, here is the equation, Fe plus H2 gives you Fe3O4 plus H2. Now, atoms of oxygen are to be balanced. So you write atoms of oxygen in reactants, in products. This is how you can write. Moving ahead, initial stages में in oxygen, hydrogen. See, your oxygen is present in water molecule, correct? So you write water molecule, and how many oxygens are present? 1. So you write 1 in H2. In products, Fe3O4, your oxygen is present. So you write Fe3O4 and 4 oxygens are present. So you denote it with number 4. To balance, you will have to multiply this water molecule with 4. Then only you can say that the number of oxygen atoms will be balanced. So you do 1 into 4, which gives you 4. You just add 4 here with the H2, and now you can see that the number of oxygen atoms have balanced. But while balancing the oxygen atoms, what increased is the number of hydrogen atoms. Because when you added 4 here, the hydrogen was also present with water. Hydrogen became 8, and your hydrogen is 2. So now we need to balance hydrogen as well. So let's balance hydrogen. Okay, so atoms of hydrogen in reactants in products. Let's atoms of hydrogen in reactants is 8, that is 4H2. In products, it is 4. So in products, you can multiply it with 4 to balance the equation. So you get Fe plus 4H2 gives you Fe3O4 plus 4H2. Here you can see now the hydrogen is balanced, oxygen is balanced. What is left is Fe. And to balance Fe will be very easy. So make a column again, write atoms of iron in reactants in products. There is one iron atom on the reactant side, but on the product side, there are 3 atoms. So all you got to do is multiply the reactant side with 1, 3, and you can get the final equation, which is completely balanced. And this is how you can balance a chemical reaction. Balancing a chemical reaction comes with practice. You cannot just solve it by just solving one. Okay, so you will have to solve many examples, and then only you will be able to get your hand clear with this part. Okay, so I end the class here. I hope you all understood that. Thank you and have a good day.